Welcome back, friends. In the previous session, we discussed about the introduction to carbohydrate, and in this session, we are going to start our discussion regarding monosaccharide as our first category of carbohydrate we will discuss. Monosaccharide, simply, it is derived from two words. The Greek word mono means single or one, and the Latin word saccharum means sugar. So monosaccharide simply means one sugar or single sugar. Monosaccharides, these are the simplest group of carbohydrates having only one sugar or saccharide molecule and are often referred to as simple sugar. Kwa hiyo hizi ni simple sugar ambazo zinakuwa zina only one sugar molecule. They have the general formula CH2O then N. N is the number of carbon atom ambayo inaweza kaanzia 3 hadi 9, from 3 to 9, the number of carbon atoms in monosaccharides, kama tutaenda kuona huko mbele. Kwa hiyo monosaccharide tunachotokea kuelewa ni kwamba zinakuwa ni zile carbohydrate ambazo zina only one sugar unit, only one saccharide. Monosaccharide, one sugar, one saccharide. They are classified according to two different characteristics. First is the placement of its carbonyl group, and in this respect they are classified as aldehydes and ketones, as will be discussed later, and we will explain different examples of the aldehydes and ketone. Lakini pia tunaweza classify kwa kuangalia number of carbon atom. Kwa hiyo the first respect in which we are classifying the monosaccharides is based on the position of the carbonyl group. Carbonyl group inapokaa inaweza katuambia kwamba huyu ni aldehyde au ni ketone. Lakini njia ya pili ni kwa kuangalia number of carbon atoms. So monosaccharides are divided up into different categories based on the number of carbon atoms as summarized in this table. This is table 2.4. Table 2.4, here it is written as table 2.3, but it is mistakenly, so this is table 2.4. It is the classification of monosaccharides based on the number of carbon atoms they contain. Kwa tukianza na 3 carbon atom inakuwa inaitwa triose, na mfano ni glyceraldehyde. 4 carbon atom inaitwa tetrose, mfano ni erythrose. 5 carbon atom inaitwa pentose, mfano ni ribose and ribulose. 6 carbon atoms zinaitwa hexoses, kwa mfano ni glucose and fructose, na 7 carbon atoms zinaitwa heptose, mfano ni glucoheptose. Unaona, this is the molecular formula of these different sugars. Unaona, na nikwambia zinaweza kuanzia carbon 3 hadi 9. So among all monosaccharide, hexoses are most common among other monosaccharide, yani katika hizo triose, tetrose, pentose, hexose ndizo ambazo ziko most common, those with 6 carbon atom, na ndizo ambazo tutazidiscuss sana in detail katika discussion yetu. So hexoses are most common, and all hexoses have the general formula of C6H12O6, but have different structural formula. So the general formula is the same, but structural formula is different. That means the arrangement of the carbon, hydrogen, and oxygen atom in this different structure, it is different. Thus, it should be noted that it is the specific relationship between the carbon atoms and the side groups which determine the nature of a hexose, sugar and its property, and later on the nature and the properties of the polysaccharide made from them. Itapo discuss kuhusu our different carbohydrates and their sources in our daily used foods. Kwa hiyo the nature and the properties of the carbohydrate which is formed depending on the nature of the hexose, how carbon atoms and different attached groups zimejiarrange. Unaona, the polysaccharide formed from the, for example, alpha glucose is different from the polysaccharide formed by the beta glucose. Maana yake inaonyesha alpha au beta glucose zinachangia sana katika tabia za polysaccharide ambayo itatengenezwa. The two most abundant hexose is glucose, which exists in two forms. The most abundant hexose is glucose. Glucose ni moja kati ya sugar ambayo tutaiongea sana. Tutaongea sana glucose. We'll talk a lot about glucose, and it is the most abundant hexose. Unaona, it exists in two forms. It exists in alpha and the beta form. So we have the alpha glucose and the beta glucose. Both alpha glucose and beta glucose, they are in ring form, and they are in ring structure. Ring, yani ring kwa Kiswahili tungesema ni kama bangili ambayo unavaa kwenye kidole. So kwenye structure za organic compound tunasema ring, maana yake ni kwamba carbon atoms zinakuwa kama katika mduara fulani hivi. The ring structure. In alpha glucose, the hydroxyl group in carbon 1 projects below the ring. In beta glucose, the hydroxyl group in carbon 1 projects above the ring. The other two common monosaccharides, they are fructose and galactose. Now here below you can see the diagram which shows these two categories of glucose molecules. Hii ndio straight chain or open chain structure of glucose molecule. Here we have the carbon number 1, number 2, number 3, number 4, number 5, number 6. Now here this forms equilibrium with this one, ambayo hii hapa inakuwa inafanya reaction ili kwenda kutengeneza ring structure. Unaona, katika ring structure tuna alpha glucose pamoja na beta glucose. Katika alpha glucose unaona the hydroxyl group at carbon number 1. Let I try to show you this. The hydroxyl group at carbon number 1 in alpha glucose projects below the ring, while this hydroxyl group projects above the ring. Tunasema projects above, manake tukiangalia upande huu kwamba iko kwa juu hivi, iko upande wa juu. Alafu tukiangalia kwa iko chini ya hii carbon number 1, unaona carbon number 1 chini yake, hii carbon number 1 juu yake, unaona. That's what we mean in terms of the hydroxyl groups. Lakini one among my student alikuwa anauliza kwamba sasa mwalimu, sijaelewa hii diagram kinatokea nini? Kinachotokea hapa ni reaction mechanism ambayo for our level of study we will not discuss it much, lakini what happens here is the reaction mechanism. Tukifika katika organic chemistry tutasoma kwamba always kinachofanyika mbele kwamba oxygen ina donate lone pair to carbon. Oxygen donates a lone pair to carbon. When it donates lone pair to carbon, carbon that cannot receive the electrons without breaking the bond to oxygen. So it will break the bond to oxygen, na inapovunja bond kuelekea kwa oxygen itaifanya oxygen iwe negatively charged. Remember kuwa oxygen ita become negatively charged. Na remember kuwa huyu oxygen kwa sababu amedonate lone pair to carbon, manake oxygen ata become positively charged. Hizi zote ni principles ambazo tunakuwa tunasoma katika organic chemistry. Oxygen ata become positively charged. So what will happen ni kwamba huyu bondi mmoja hapa manake tayari atakuwa ameshavunjika, amekuja huko. Kitakachofanyika ni kwamba this oxygen now will donate electrons to hydrogen, and by donating the electrons to hydrogen, this hydrogen will break bond, releasing the electrons back to oxygen. Zinavyo-release electron to oxygen, that means what happens ni kwamba huyu oxygen ata accept electron, ata neutralize this positive charge, and then this hydrogen will be taken by this one, forming the hydroxyl group. So tutakuwa tuna hydrogen hapa which is red is taken by this oxygen, forming the hydroxyl group, and then finally the bond which remains here is only single bond. This bond it is broken to supply electron there, and this bond is broken to supply electron here to oxygen. Na ndio maana unaona huku finally tunakuwa na bondi moja ile pale ambayo ni red, na pia hapa tuna bondi moja ambayo ni red. That is just the summarization which can aid you understanding different things which are happening here. It can just aid you to understand different things which are happening here. However, we have a lot of mechanisms ambazo tunaweza kuzidiscuss sana katika organic chemistry. Katika biochemistry hatuzidiscuss sana. Kwa hii ni open chain structure, hii hapa ni equilibrium structure, lakini huku tuna alpha glucose na hii hapa ni beta glucose. Kama tulivyosema kule mwanzoni katika description kwamba In alpha glucose, the hydroxyl projects below the ring, while in the beta glucose hydroxyl at carbon number 1 projects above the ring. So it's carbon number 1, number 2, number 3, number 4, number 5, and then carbon number 6, it is outside the ring. And here carbon number 6, it is outside of the ring somewhere there. Kwa that's all. Na tunachokisema ni kwamba in the solution form hizi state zote huwa zinakuwepo. 0.02% it is open chain structure, 36% is alpha glucose, and the 64% is beta glucose in the solution form is beta glucose. From there tulikuwa tunaelezea kuhusu alpha na beta glucose na projection of the hydroxyl group in these two molecules of monosaccharides. So now we can go to discuss the physical properties of monosaccharides. Physical properties tunakuwa tunazungumzia vitu kama test, kwamba sugar tukionja itakuwa inanogaje na vitu vingine vinafanana na hivyo. So first, they are small molecules of carbon, hydrogen, and oxygen. So they are small molecules of carbon, hydrogen, and oxygen. Second, they are sweet in taste. Third, the name sugar. They are readily soluble in water. They are sweet in taste, kwamba zinanoga. Tatu, they are readily soluble in water, zinayuka kirahisi. Nne, they are crystalline solid at room temperature. Maana yake ni crystal, they are crystals at room temperature. From there we have other common monosaccharide kama tulivyosema pale mwanzoni kwamba the other two common monosaccharide is hapa. Let me magnify this image and try to show you well this monosaccharide in such a way that you see them well. Alright, 200, how much? Let me magnify there, 250. Nice. So I hope now you can see well. This is glucose as I have shown it in the previous page. Glucose inavyoonekana, na ukiambiwa tu molecule ya glucose tunakuwa tunazungumzia alpha glucose. Hydroxyl at carbon atom 1 and projects below the ring. You can see kwamba glucose na this last sugar galactose they are mostly similar, as if they are similar in some way. Unaweza kuona the major difference between hii ni alpha glucose, this is alpha glucose. Ingekuwa ni beta glucose, manake hiyo hydroxyl ingekuwa iko wapi? Upande wa juu kama ilivyo huko beta glucose. Hasa beta glucose na galactose wametofautiana tu hapo kwenye carbon ya 4. Carbon ya 4 glucose zimeweka hydroxyl chini, lakini galactose carbon ya 4 imeweka hydroxyl juu. Fructose yenyewe ni ketone. Kwa fructose inatofautiana na glucose pamoja na galactose, na yenyewe inatengeneza the 5 membered ring ambayo tunakuwa tuna C2 hydroxyl pi na C2 hydroxyl pi. Unaona kwa carbon ya kwanza hii hapa, it is counted as carbon number 1, number 2, number 3, number 4, number 5, then number 6 against there. These are the ring structure of the 3 common exoses, yani sugars and carbon 6. This is the ring formula za hizo common monosaccharide. But here we have the structural formula, I mean the straight chain structure of these molecules. Here is glucose. Na unaweza kuona glucose carbon number 1, number 2, number 3, number 4 hydroxyl iko right. Katika hii hapa galactose hydroxyl iko left. You can see the names here, the glucose, fructose, and then galactose. So fructose, it is ketone. Na unaweza kuona observe the ketone functional group, how it is. Tuna carbon, then tuna carbon nyingine na carbon, then the ketone functional group it is there. So fructose is different from these two other molecules katika combination hiyo hapo. Kwa hiyo kiufupi hicho ndicho ambacho naweza nikakueleza, hicho ndicho ambacho naweza kueleza. So we finished here about the physical properties. We can move to the chemical properties of monosaccharide. The monosaccharide, they are reducing sugar. That means the exoses can reduce medicated solution, the copper 2 ion in medicated solution, which is blue in color, to copper 1 ion which is brick red precipitate in color, hence the name reducing sugar. Kwa hiyo reducing sugar zina reduce copper 2 sulfate ambayo ni blue in color kwenda katika brick red PPT. So hii ndio jina ambalo linasababisha sugar ziitwe reducing sugar, and this because of the presence of the carbonyl carbon, kama tutaenda kudiscuss in detail katika carbonyl compound kwenye organic chemistry na utaelewa zaidi. Namba mbili, they cannot be hydrolyzed into anything simpler than themselves. Hauwezi ukazidigest. Tatu, they consist of 3 to 9 carbons. They consist of 3 to 9 carbon. Number 4, they exist in ring form or open chain structure. Lakini yeah, let I mark the end of this session here. In the coming session we discuss about the functions or laws of monosaccharide, and we'll move to discuss about the aldoses and ketoses and what are their laws in the living system. So let I wish you nice studies. Just share this session and tell more people to visit our channel. Thank you. Let's meet in the coming session.